I've gone ahead and typed in our observed values, our expected values. I've only numbered the categories instead of typing out their descriptions. Here are, I've typed the formula that I'm going to use. Now, in the last video, I started to show you what would happen if you forgot the equals sign. So remember, we need an equals to tell the spreadsheet that we're performing a calculation. And I didn't do a very good job of showing you what would happen, so let me just go ahead and do that. I want to do the number in B2 minus the number in C2. I want to square that and divide by the number in C2. When I hit enter, nothing happens. That's because without the equals, the spreadsheet doesn't know that we're performing a computation. So I need to edit this cell and get an equals on the front of it. You can obviously just start over, but it'd be kind of nice to edit it. Okay, there we go. Now to fill in the same formula down the column, but adjusting for the numbers in each row, I need to have this cell selected. I look for the little square on the lower right, and I need my cursor to be across, not this arrow and not the hand. Can I get the hand? Yeah, there's the hand. You don't want that either. You need the cross to tell it, use the formula and adjust for the numbers in each row. Now I want to add those numbers up to get my test statistic, my chi-square. So I need the equals and then sum. And I'm going to go ahead and click and drag to select all those boxes. Then I need to manually close the parentheses and hit enter. So that gives me the sum of those chi-squared values. I can get the p-value using the function chi-distribution, chi-dist, so equals chi. You can type in dist. I'll do that this time since I think last time I clicked on the list to select it. I get this sort of instruction here saying put in your chi-squared value. So I'm going to click the box, the cell that has the chi-squared value. Then I need a comma. Then I need to put in the degrees of freedom. The degrees of freedom is one less than the number of categories. Since there's 4 categories, I have 3 degrees of freedom. I need to close the parentheses, and then I hit enter to say I'm finished. Then remember, we have a way of using the original table of data to also compute the p-value. That's a good shortcut or a good way of checking the p-value. And for that, you go equal chi. And instead of picking chi-dist, we use chi-test. And we don't have to select it from the list. We can actually type it. Then I start the parentheses, and that tells me I'm going to put in the observed range. In other words, the set of observed values, comma, and expected range means the set of expected values. So our observed values are in those 4 boxes. So I click and drag, click, hold, and drag to enter that range there, then the comma. And as I mentioned in the last video, if you don't like clicking and dragging, you can type them out. So I can type C2 colon C5 if I prefer to do it that way. Then I close the parentheses, click enter, and I confirm that yes, the p-value is supposed to be 0. From our work on the spreadsheet, we know that the test statistic, chi-square, is 60.689. I'll round to 3 decimal places. And the p-value, it said, was 0. Now, that's actually an approximation. The probability can never be exactly equal to 0, but what the sheet was telling us is that the probability is so small it gets rounded off to 0. We need to compare that to alpha. Let's see, we're using the 5% level of significance. In other words, alpha was 0.05, and 0 is certainly less than 0.05. Since the P is low, the null must go. We reject the null hypothesis. Which means we can conclude that there is sufficient evidence at the 5% level of significance to support the claim that the distribution of professional hockey players birth dates is not uniform throughout the year. One last comment about this example. We didn't exactly prove or support Malcolm Gladwell's claim. So he claimed that more hockey players are born in January through March than during the rest of the year. We don't have his specific idea of how many more are born January through March. In other words, we don't have a probability from him or a relative frequency from him. So we don't have enough information to test whatever hypothesis is inside his head. So what we did to just get some idea was we instead tested the hypothesis that they're not all the same. So we tested something a little bit less specific than his claim. But that's the best we could do given the information we had. Okay, I think that wraps up this video. Thanks for watching, and I'll see you in the next one.